Hi everyone, welcome back. We're going to continue with 3.3 today. So 3.3, real zeros of polynomial functions. Today we're going to be focusing on the rational zero test. Thus the essential question, how can I use the rational zero test to help find real zeros? So yesterday we were talking about how we can use synthetic division. And if we're given certain factors, we can actually determine via synthetic division if certain values actually are factors of a higher degree polynomial. Today, we're actually going to deal with higher degree polynomials where they don't give us any factors to start with, and you actually have to choose some numbers to use synthetic division with. Now, we don't want you choosing numbers randomly because otherwise that's going to take a really long time, and that's where the rational zero test comes in. So what you guys need to do first is go ahead and copy down whatever is inside here, describing the rational zero test. So it might look a little bit complicated right now, but we're going to go ahead and practice it several times. The most important part is this part right here, rational zero equals P over Q. P is going to be the factor of the constant term, and Q is a factor of the leading coefficient. We're going to go ahead and practice using the rational zero test first, before we even factor out the entire polynomial. Okay, so go ahead and copy that, pause if you need to. I'm going to zoom in for those of you without the book at home. And now let's go ahead and start with example 1. So in example 1, all I want us to do is to use the rational zero test. So example 1, use the rational zero test. And we're going to use it with the following polynomial. X cubed plus 3x minus 2 equals 0. And here's how you determine everything. P is going to be the factors of our constant. Okay, so you might want to make a note there, constant. So with this one, we actually have several factors. We have 1. Then we can have negative 2. We could also have negative 1 and a positive 2. So what we actually have for just the constant is plus or minus 1, plus or minus 2. And then Q is going to consist of all of the factors of the leading coefficient. In other words, the coefficient of the highest degree term in your entire polynomial. In this case, we have x cubed and the number in front of it, 1. So, leading coefficient. And because our leading coefficient is just 1, the only factor that we actually have is plus or minus 1. Okay? Here, you're going to have to find out what P over Q is, and we have to test every single one of them. Okay, so P over Q could consist of positive 1. Let me actually write it out. So let's say I use the positive 1 and use it over positive 1. Then I have negative 1 over positive 1. 2 over positive 1. Negative 2 over positive 1. I could also check it with the negative ones, but in reality, it actually just leads to 1, negative 2, positive 2. So these are the 4 terms that I'm going to get from using my rational zero test. So 1, negative 1, 2, and negative 2. What you need to now do is check, do these actually result in a rational zero? The way to do that is either by using synthetic division, or you can use just plug in, actually. So I'm going to go ahead and plug in each one of these. So let's say that we use 1. So f of 1 will be 1 cubed plus 3 times 1 minus 2. The reason I'm choosing to plug in is because we're dealing with a pretty small polynomial in this case. So I actually want to just go ahead and plug in. So 1 plus 3 minus 2. So that's 4 minus 2, and that's going to be 2 equals 0, so that's not true. 1 is not a rational zero. Now I'm going to go ahead and use my next couple. X equals -1. So f of -1, -1 cubed plus 3, -1 minus 2. That's -1 minus 3 minus 2. That is definitely not equal to 0. That's going to be a really negative number. Then we test x equals 2. F of 2 equals 2 cubed plus 3 times 2 minus 2. That's going to be 8 plus 6 minus 2. And that is also not going to equal to 0. 14 minus 2. Finally, the last one we can test. We'll see if this even works. F of -2 equals -2 cubed plus 3 times -2 minus 2. That one will be -8 minus 6 minus 2. And again, we end up with this huge negative number. So by plugging in all of my rational zeros, or my potential rational zeros, I actually realized that this polynomial has no rational zeros. And I did have to go through a lot of work to do that, but it helps me realize that I don't have any rational zeros, and it's basically not going to work out all that well. Okay? So, with this, that's actually all I have to do for this problem. And in the next one, things are going to work out a little bit better, because in that case, we're actually going to get some rational zeros. Okay? But that's just a demonstration of how to use the rational zero test using the P over Q. And now what we're going to do is actually jump into example 2, where we use the rational zero test and are actually able to factor out and factor the polynomial into smaller terms. So example 2, we're going to factor and find the rational zeros. So find the rational zeros. Of, and then here's our function, f of x equals 2x cubed minus 15x squared plus 27x minus 10 equals 0. Now this one, as you can tell, is actually not going to be that pretty. For p, I have a ton of different factors. I start off with 1, and over here I have 10, because 1 and 10 will get us that -10. Then I also have 2, which is in connection with 5. So those are all my possible factors for P. Q, on the other hand, is a lot easier. Since I have a 2, my only factors are plus or minus 1 and plus or minus 2. Now, the only issue is, as you might recall, is that I have to test P over Q for all of my possible rational zeros, which means I have a huge collection of possibilities. I have plus or minus 1, plus or minus 1/2, plus or minus 2. Here, if I do 2 over 2, I end up with 1 again, so I don't have anything there. Then I get plus or minus 5, plus or minus 5 over 2. And then if I do 10, well, actually I do get plus or minus 10 there. 10 over 2 would just get me 5 again, so I don't have to put that again. But these are all of my possible rational zeros. That seems really intimidating, and to be honest, a lot of problems might actually turn out this way. At this point, because we've already narrowed it down to this selection, we do have to test out until we end up with potential factors. Okay? So I'm going to go ahead and just test out 1 using synthetic division. So with this one, I get 2, -15, 27, and -10. Using synthetic division, we get 2 right there, 2 there, -13. That's going to be -13 and 14. 1 and 14, I get 14, and end up with a remainder of 4. So because I end up with a remainder, this rational zero, or potential rational zero, is not a factor. So, did not work. Let's go ahead and test our next one. I'm going to go out on a limb and test out 1/2. Let's start with 2. The reason I start with 1/2 is because I see that 2 right there and I'm thinking, I can cut it down into a 1 or something. So let's rewrite everything. 2, negative 15, 27, and negative 10. Multiply 1/2 and 2, I get 1. That gives me negative 14. Half times negative 14 will get me negative 7. 20. Half and 20. 10. Thank goodness it works. So at this point, I can go ahead and take that 1/2, and I have x minus 1/2 times 2x squared minus 14x plus 20, all equal to 0. And at this point, because I end up with a quadratic, I can actually factor this without having to do any more synthetic division. If you get this lucky, you can just proceed and factor as you normally would. If you don't get so lucky, then you have to continue with synthetic division until you get a remainder of 0 and have something that you can actually work with. All right, so I'm just going to go ahead and finish this one. X minus 1/2 is still there. Here I'm going to factor out the GCF of 2. Take out that minus 7x plus 10 equals 0. I'm going to go ahead and move the 2 to the front just because I don't like it there. 2x minus 1/2. And then here, this one will break down into x minus 5 and x minus 2 equals 0. Okay, this would be an acceptable answer. Only thing is I have a half right there. I don't really want to deal with that. I can go ahead and distribute this 2 and make this a little cleaner. So this one can be read as 2x minus 1, x minus 5, x minus 2 equals 0. Okay? So by using the rational 0 test, using synthetic division, and then factoring, I was able to successfully factor this great big polynomial down to these 3 terms. Okay? And that's going to be our challenge for the next assignment. So make sure to be prepared to be patient because you're going to have to test out quite a bit of values for several of these problems. If you get lucky, you'll choose the right one right off the start. Otherwise, again, practice some patience. Okay? Rewind, replay as needed. Otherwise, go ahead and move on to the Google Forms. Have a great day, you guys.